What's up, everybody? Welcome back to a video. In the last video, we were taking a look at the concept of the mole. And what we got introduced to was how the mole is really just similar to this word dozen that we're pretty familiar with. How 1 dozen represents 12 things. We now have this quantity of the mole, which represents a certain value, which is 6.02 times 10 to the 23rd. Large number. We're dealing with small things here in chemistry, so it obviously makes sense that we're dealing with a very large number of things that we can now use to quantify in a smaller way, which is called a mole, or I guess a bigger way. Depends on how you look at it. But what we used the mole for was to perform some conversions where if we know that 1 mole is equal to 6.02 times 10 to the 23rd, we can use the conversion factor that is listed here in order to convert from atoms of something to moles of something, or vice versa. So we were able to do that. We're going to continue to talk about the mole today. However, we're going to look at it in a different way. In this regard, we're going to be looking at it and how it pertains to a mass. So obviously things that contain matter have a mass. And when we look at the periodic table, we notice that each element has their own specific mass. And what we've been looking at all this time is what is called molar mass. All representative particles come in different masses and sizes. So we look at the periodic table, we see that all these elements come in different masses with different numbers of protons and neutrons. And basically what we're looking at is what is called the molar mass. The molar mass is the mass of 1 mole of a particular substance. It could be an element, it could be a compound, and we have the perfect tool to be able to determine all this stuff right there on the periodic table. If we're looking at things like carbon, carbon is one of my favorite elements, but carbon has a mass of 12.011. That is the molar mass of carbon. Now, copper, on the other hand, has a mass of 63.546. That is what the molar mass of copper is. Each of those are different elements, therefore they have different masses, all of which still contain the same number of particles, 6.02 times 10 to the 23rd, but those number of atoms all have different masses. So molar mass is going to be an important concept for us, and like I was kind of alluding to, we can determine the mass of anything using the periodic table, and that is going to represent how much 1 mole of that substance weighs. So if we want to determine the molar mass of a compound, chances are we're going to be determining the molar mass of compounds way more often than we are elements. So we're going to need to be able to practice and understand how to do that for the purpose of these conversions. So the first part of this is just understanding molar mass and how to calculate that. That's what we're going to work on right here. So we're going to be needing to understand or know the molar mass of each element that's in a compound. And then if we can do that, looking at a periodic table, we can then determine the mass of the compound itself. So in H2SO4, sulfuric acid, there are 2 hydrogens, there's 1 sulfur, and there are 4 oxygens. All of the elements in this compound together combine to give us the mass of that entire compound. So in order for us to know what the mass of this compound is, we need to figure out what the mass of each element that contributes to that compound is, and then obviously adding those up will give us the mass of the whole compound. So in H2SO4, there are 2 hydrogens. In 2 hydrogens, 1 hydrogen has a mass of 1.008. But since there are 2 of them in the formula, that's what this subscript 2 is telling us, we're going to multiply the mass of 1 by 2 because there are 2 of them. Got this number from the periodic table. This is always available to you. Shouldn't have any issue finding it. We'll practice this a heck of a lot in class. Now, we obviously need to add the mass of our 1 sulfur to that because that also is contributing mass to the overall compound. If 1 sulfur has a mass of 32.06, we need to add that 32.06 to our already existing mass from the hydrogen. And then we can't forget about our 4 oxygens. SO4, there's 4 oxygens in the compound, so we have 4 oxygens, each of which has a mass of 15.999, basically 16. So we're going to take 4 and multiply that by 15.999. Now the sum of each of these elements that are in the compound is going to give us our overall molar mass, and that is what is listed right here. 2 times 1.008 plus 1 times 32.06 plus 4 times 15.999 gives us an overall mass of 98.072 grams per mole. This is the unit for molar mass, grams for every mole, which is now telling us that if we have 1 mole of H2SO4, it is going to have a mass of 98.072 grams. That's what molar mass is, telling you how much mass is in 1 mole of a substance. So using this, I don't think that this is too difficult. As long as you have a periodic table, you should be able to easily find these molar masses. So on the next slide here, I have some practice. These are in your packet. I'm happy to go through NABR with you, and then you'll be responsible for the remaining 5 on your own to show me the next time I see you guys. So sodium bromide, you're obviously going to need a periodic table, so we'll need one of those handy. When you look at sodium, you'll see that sodium, there's only 1 in this formula, and it has a mass of 22.99. There's only 1 bromine in this formula, so if we find 1 bromine, which has a mass of 79.90, we just know that 1 sodium and 1 bromine, add these 2 values up, and that's going to give us a molar mass of 102.89 grams per mole. So I don't think we're going to have, like I said, we're not going to have any issue solving this. I think that you guys will have an easy time with this. Now, this is just a piece of the puzzle that we're trying to put together. So obviously we need to master this before we can get to the next part. So that's where these 5 examples should be sufficient enough practice for you to at least get the main idea down and, get a routine set for yourself. But there is actually a larger purpose for being able to use for understanding molar mass, and that is, of course, for the purpose of performing calculations and performing some conversions. So we have the mole mass relationship. The mole mass relationship can be used to convert between the number of moles of a substance and its mass. So we have a conversion factor here. That conversion factor is that the molar mass is equal to 1 mole. So this is, again, one of those tools that we're going to use for the purpose of converting. And it becomes really helpful for us to, if we know we have a certain number of moles of something, then we can figure out a mass, which then we can go back in the lab, put on the scale, and then we have a mass of something that we can use for the purpose of an experiment. So this is very useful, probably actually more useful than being able to determine how many atoms you have, because a mass is something that we can actually utilize or observe using our scales back there in the lab area. So I want to do a sample problem with you guys. I want to walk you through the process through which we can solve this. And then once we do that, we will we'll have you try some practice problems on your own and continue this whole mole journey that we've been going on. So items made of aluminum, such as aircraft parts and cookware, are resistant to corrosion because the aluminum reacts with oxygen in the air to form a coating of aluminum oxide. That formula is Al2O3. What is the mass in grams of 9.45 moles of Al2O3? So essentially, there's a lot of setup work here. There's a lot of words that don't necessarily pertain to the actual question, but it's good to have a background. Essentially, what we need to focus on is if you have 9.45 moles of aluminum oxide, how many grams of aluminum oxide does that represent? So we're going to go ahead and take a look at this. I've got this written down on my paper right here, and I want to walk you guys through how we would go ahead and solve this. So of course, I got some reminders here. We know that our conversion factor is that molar mass is equal to 1 mole. So we know that this relationship means that 1 mole over molar mass or molar mass over 1 mole. These are our conversion factors that we're going to use to plug in this conversion. So let's just first start by setting this up and giving ourselves some sort of format that we can use to start plugging in some values. So we know that we're given 9.45 moles. So I'm going to start with 9.45 moles of Al2O3. And I'm just going to set up my conversion table right here. We're just setting this up and making sure that we incorporate the necessary units before we start plugging in some values. So keeping those same ideas constant, where we know we want to cancel out our units of moles and we want to convert that to grams, we should know by now that in order to do that, we need to put moles bottom And what that's going to do is give us grams on the top. So now that we have this, got a format here, we know that 1 mole is equal to the molar mass of a substance. So this doesn't necessarily give us something to plug in. We actually need to do a little bit of work on figuring out what this molar mass is, and then we can plug that in. So this part does require you to look at Al2O3 and figure out what its mass is. So in Al2O3, we have 2 aluminums. Now, of course, you probably have a periodic table handy, so we're going to be able to use that. Aluminum's right here. I know that's really small, but the mass is 26.98. And then we have 3 oxygens, so I'm going to add my 3 oxygens here. I'm going to multiply that by the mass of oxygen. Of course, you have your periodic table for that. On this periodic table, it says 16.00, so that's what I'm going to include. And by doing this, we can figure out our molar mass. So I'm going to get out my calculator, plug this in, 2 times 26.98 plus 3 times 16. We get a molar mass of 101.96. So this is what we are going to plug in this part of our conversion, 101.96. What we're seeing here is that for every 1 mole of aluminum oxide, we have the molar mass of aluminum oxide, which is 101.96. We're going to be able to convert out or cancel out those units, leaving us just with grams of Al2O3. So now what we need to do is we're going to multiply by our 9.45 by 106, and then we're going to divide that by 1. So I still have that set up here. So all I'm going to do right now is just to, make things a little bit quicker. I'm just going to multiply this value by 9.45. And what we see is that when you take 9.45 moles of aluminum oxide, what that ends up giving us is 963.52, and then our units for that would be grams. I kind of ran out of room there, so that's a little bit sloppier than what I would have liked it, but hopefully you guys get the idea. By taking a number of moles and determining what the molar mass is from the formula that's given, we can use the molar mass as a conversion factor to go from moles to grams, or even the vice versa, grams to moles, to get ourselves our answer. So I want to see what you guys can do regarding this. You should have, I think it's 3 examples, 3 practice problems in your packet to be able to work through. These are also practice problems that I would like for you to get done by Monday, so I can check in with everybody and see how we're doing. And from there, we'll see what kind of other things we can sprinkle in there. I really appreciate you guys taking the time to watch this video. I hope that things were clear for you. And I hope that we're doing good with chemistry and in everything in life. Thanks for tuning in. We'll catch you guys later. Peace.